Welcome to the deep dive. Today, we're diving into the world of microservices, but we're going a little deeper than usual.
Yeah, we're talking about a design pattern that's really important for reliability in microservice architectures. It's called the Transactional Outbox.
Transactional Outbox. Okay, I'll admit that sounds a bit like tech jargon to me, but I'm ready to decode it with you. What's the problem that this pattern is trying to solve? It's all about communication between those microservices.
Yeah, you got it. Imagine this. You're buying something online. So your order needs to be recorded, and at the same time, the warehouse needs to be notified to, actually ship it. These actions, they happen in different microservices, but they need to be in sync, and that can be really tricky.
Right, because if one fails, you don't want the other one to happen anyway. Like, I definitely don't want to get a shipping notification if my payment didn't even go through.
Exactly. Traditional methods, they often aren't really the best fit for this kind of distributed system, and that's where the transactional outbox comes in. It basically adds the safety net to make sure that these actions happen reliably and, just as importantly, in the correct order.
Okay, I'm definitely intrigued, but can you break it down for me a little bit? How does this outbox actually work?
Okay, so think of it like sending a postcard. Before you actually drop it in the mailbox, you write it out and then you keep it with you for a little bit. In the digital world, our postcard is the message that a microservice needs to send, and the outbox is basically a special table that lives in the database.
So instead of sending that message directly, it first goes into this outbox table.
Yes, exactly. And this is actually the key part. Adding that message to the outbox, it happens within the same database transaction as that main action, like updating your order information, for example. It's like jotting down a little reminder on that postcard before you actually send it.
I see. So even if the system, like, crashes before it can send the message, it's still safely recorded in the outbox.
Precisely. Now, this is where the message relay comes in. The message relay is a separate process that's constantly checking the outbox for any new messages.
So it's kind of like a dedicated mail carrier that picks up messages from the outbox and then delivers them to the correct microservice.
Exactly. This way, even if one part of the system fails for some reason, the message is never lost. It guarantees that once that database update is successful, the message will get delivered, which ultimately maintains data consistency.
This is so fascinating. It's like this whole behind-the-scenes system that's making sure everything runs without a hitch, even when things go wrong.
And it gets even more interesting. There are actually different ways that you can implement this message relay, and each of them has its own pros and
Oh,
cons.
tell me more. I'm already starting to see how this is a lot more than just a simple outbox.
Absolutely. The source material, it highlights two common patterns. The first one is called transaction log tailing, and then there's the polling publisher pattern. And basically, they differ in how they actually monitor the outbox for new messages.
Okay, let's unpack those a bit. Starting with transaction log tailing. How does that one work?
Okay, so imagine you have this watchful observer, and this observer is constantly monitoring the database's transaction log. Now, this log keeps a record of every single change that's made, and that includes adding those messages to the outbox.
So it's like a real-time feed of all the database activity.
Exactly. So as soon as a new message pops up in the outbox, the observer immediately sees it, picks it up, and then delivers it straight to the microservice that's waiting for it.
Wow, that sounds almost instantaneous.
Yeah.
Are there any downsides to being that, on top of things?
Yeah, it's definitely a very reactive approach, and that can actually be pretty resource intensive if you have like a ton of messages flying around. But for applications where that near instantaneous delivery is super important, like say financial transactions or something like that, it's really valuable.
That makes sense. So what about the other one, the polling publisher? It sounds a bit more, laid back.
Yeah, you could say that. So instead of constantly watching the transaction log, like that observer we talked about, the polling publisher basically checks the outbox for new messages, but it does it at regular intervals.
Oh, okay. So it's like checking your email every hour instead of having those new messages, pop up right away.
Precisely. And of course, this is a lot less resource intensive, but the trade-off is that it does introduce a slight delay in the message delivery.
Got it. So choosing between the two, it's really about finding that balance between speed and efficiency, depending on what the application actually needs.
Exactly. And there are even like hybrid approaches out there that try to combine elements of both, especially for, more specialized scenarios. But I think the key takeaway here is to really understand what these options are and then pick the best one for your specific use case.
That makes total sense. So we've talked about how the transactional outbox helps maintain that data consistency, which is obviously super critical. But Are there any, like, drawbacks or challenges that come with this pattern?
That's a really good question. So, while the transactional outbox itself, it's a pretty robust pattern, right? Its effectiveness really depends on how well it's actually implemented. So, for example, if a developer, they forget to actually publish the message after the database has been updated, well, then you're going to have a problem.
Ah, so there's still that human element that we can't really escape, huh? It's
Yeah.
not totally foolproof.
Exactly. And another challenge is how you actually handle duplicate messages. Remember, that message relay, it could crash and then it might restart, and then there's a chance it might accidentally send the same message twice.
Oh, right. Yeah, that makes sense. So how do you prevent that from causing problems? Like, how do you avoid, getting two orders shipped instead of just the one you placed?
Okay, so that's where this concept of, and it's a bit of a mouthful, idempotency comes in. Idempotency basically means that processing the same message 2 times has the exact same effect as processing it only once.
Okay, so the microservice that's receiving the message, it needs to be designed in a way that it can handle those duplicate messages gracefully, right?
Yeah.
Like it needs to be able to recognize if an order has already been shipped.
Exactly. It's something that's super important to keep in mind when you're designing systems that use this pattern. You need to anticipate those potential issues and then make sure that your microservices can handle them without causing data to get all messed up.
Right. So this pattern is really all about making sure those communication channels between the microservices are super reliable. It's about ensuring that the messages get through no matter what, even if there are, hiccups along the way. It seems like a really critical piece of the puzzle when you're building applications that need to be both robust and scalable.
Absolutely. And it actually works even better when you combine it with other patterns, like, for instance, Saga and domain events. They address different aspects of these distributed systems, but they can all work together to make things even more reliable and keep that data consistent.
Okay, now you're just using more tech jargon on me.
Yeah.
Can you unpack those a little? What are Saga and domain events all about?
Okay, so think of a Saga like a way to manage a really long-running business transaction, one that might even span across multiple microservices. So let's go back to that online order example. So it might involve things like reserving the item, then processing your payment, and then finally actually shipping that order out to you.
Right. It's a whole chain of events that need to happen in a very specific order.
Yeah. Exactly. So a saga pattern, it makes sure that those steps all happen in the right sequence. And really importantly, if any step along the way fails, it can actually orchestrate what we call a rollback. And that basically undoes all of the previous steps. It prevents data from getting out of whack.
That's really important. So you don't end up with like a half-completed order that messes up your inventory.
Yeah.
But how does this tie back to the transactional outbox?
So each step in that saga, it often involves sending messages back and forth between those microservices, right? Well, the transactional outbox is there to make absolutely sure that those messages are actually delivered, even if one of the services decides to crash right in the middle of the saga.
Oh, I see. So it's like the reliable messaging backbone of the whole saga pattern, making sure those critical communications happen no matter what.
Precisely. And that actually brings us to domain events. They're basically like little notifications that a microservice sends out when something important happens within its own little domain.
So like an alert that's like, hey, this item's been reserved, or the payment for this order, it went through.
Exactly. Those events, they let other microservices know what's going on so they can then react and take the appropriate actions based on those changes. And again, that transactional outbox, it's playing a key role here in ensuring those events are actually delivered reliably.
So it's all interconnected. The transactional outbox, saga, domain events, they're all working together to create this really robust and consistent way for those microservices to talk to each other. It's honestly amazing to see how these patterns can all build on each other like that.
It really is. It kind of highlights the elegance and the complexity of designing these systems. They have to be super powerful, but they also need to be really reliable, especially nowadays where, applications are becoming more distributed and interconnected all the time.
This has been incredibly insightful. I feel like I've gained a whole new understanding of how the transactional outbox works. It's more than just some technical detail. It's a fundamental part of how we make sure data is consistent and reliable in this world of microservices.
Absolutely. It's one of those foundational patterns that a lot of the applications we use every day rely on, often without us even knowing it's there, working behind the scenes.
That's the beauty of a well-designed system, right? They just work. And we can focus on what we need to do without having to worry about all the complicated stuff happening in the background.
I completely agree. And I think the more we actually understand these underlying principles, the more we can appreciate the ingenuity and the amount of effort that actually goes into building these digital systems that we've come to rely on so much.
Well said. Now, for anyone listening who is as fascinated by all of this as I am, are there any specific technologies or tools that people typically use to implement this transactional outbox pattern? I'd love to be able to give our listeners a starting point for, if they want to explore this a little further on their own.
Yeah, for sure. So there are several message brokers out there, things like RabbitMQ or Kafka.
Hmm.
They're pretty popular, and they're often used to handle that message delivery part of these systems.
Ah, yes. Okay, I've definitely heard of those.
Yeah.
They basically act like those central hubs that route all the messages between those different services, right?
Exactly. They provide that necessary infrastructure for reliable message queuing and delivery, and that makes it a lot easier to implement these patterns, like the transactional outbox. And there are even some open source libraries and frameworks out there that are specifically designed to streamline this whole process, and you can find them for pretty much any programming language.
This is all so fascinating. It's really amazing to get even just a small glimpse into how these complex systems work and what tools developers use to actually build them.
It truly is a fascinating field, and we've honestly just barely scratched the surface here. But I think even having a basic understanding of these concepts, it can be really empowering, even for folks who aren't, software engineers.
Absolutely. It helps us appreciate the complexity of the technology we use every single day and makes us more informed users overall.
Exactly. And it opens up this whole new world of possibilities when we start to understand how these systems are designed and, more importantly, how they can be used to solve real-world problems.
This has been a really enlightening deep dive. I feel like I have a whole new appreciation for the intricate workings of software and all the elegant solutions that make our digital lives possible.
It's been my pleasure to be here and guide you through it. And remember, knowledge is power, and the more we understand about these systems, the more empowered we become, not just as users, but as creators as well.
Well said. Now, before we wrap up with our final thoughts, we want to take a quick moment to thank our amazing sponsors for supporting this deep dive. And we're back. So that was quite a deep dive into the Transactional Outbox, Expert Speaker.
I have to say, this whole journey into microservices has been really eye-opening.
Yeah, it's been great to be able to unpack all of that with you. And the Transactional Outbox, it might seem kind of like a behind-the-scenes player in all of this, but its impact on our digital experience, it's huge.
Absolutely. So as we wrap things up here, what would you say is the key takeaway you want our listeners to walk away with today?
I think it really boils down to this. The Transactional Outbox, at its core, it's really about building trust.
Trust.
Yeah, it's about trust that these systems, they're going to communicate reliably, that the data is going to stay consistent, and that even if there are hiccups along the way, that intended outcome, it's going to prevail. It's kind of like that, underlying confidence we all have when we click submit on an order or when we're transferring money online, right? We just trust that it's going to go through without a hitch.
Precisely. It's like the silent guardian of all those digital agreements we make, ensuring that all those transactions and interactions, they just occur as we expect them to. And I think in a world where we rely on these digital systems more and more every day, that kind of reliability, it's pretty much invaluable.
That is a great way to put it. Expert speaker, thank you so much for taking the time to really break down this often overlooked part of software development for us. This deep dive has definitely given me a whole new appreciation for those kind of intricate mechanisms that keep our digital lives running as smoothly as they do.
It's been my pleasure. And remember, even if you're not a tech expert, just understanding these basic concepts, it can make you a more informed user and empower you to ask the right questions about the technologies that we're all interacting with on a daily basis.
Absolutely. And to everyone listening, thank you for joining us on this deep dive into the world of microservices and the transactional outbox pattern. We hope you found it insightful. You can now follow code Impact Podcast on Apple Podcast, Amazon Music, Spotify, and other podcast networks. For anything tech, product, money, books, life, visit https://www.boxpiper.com. Until next time, keep those brains engaged and never stop exploring.